Hello everybody, welcome back to another video for Math 10. This is EDA Unit 3 and the focus of this unit is going to be on plotting. And this video in particular is going to be an introduction to plotting, but in the context of the grammar of graphics. So if you've done plotting in Python before, what you've probably done is used Matplotlib, and this is great, and it's very flexible, so kind of the benefits, very flexible. And it's widely used, right? So lots of resources available, easy to look for help, that kind of stuff. On the other hand, our focus in Math 10 is on data science. So because of that, we have much more specialized plotting libraries for us to use. So what do we mean by specialized? Well, we mean we can get results much faster. So get results much faster. And in some sense, there's going to be less tinkering because it's designed for what we want to do, versus Matplotlib is very flexible, so we might need to do a little bit more tinkering to get what we want. Cool. So what are going to be kind of like the stars of Math 10? What are the libraries that we're going to use? So there's three in particular, and I'll list them as Altair. Then we have Seaborn. And lastly, Plotly. And so what I'll say about these three is they're very similar to each other. So all similar to each other. But less so to Matplotlib. So not so much to Matplotlib. And by far, so Altair is going to be the most important one for us this session. So most important for Math 10. So I'll say most important for us. This is really going to be the one that we spend the most time on. And as for Seaborn and Plotly, so I'm going to show you the basic syntax. So I'll say we'll see the basic syntax. But really not much else. So what that means for this class is that if kind of you're wondering when we get to the final project, what could you do as one of your new things? What could you spend more time learning on your own? Going more in depth into Seaborn and Plotly is one idea. Like I said, Altair really is going to be our focus, but I do want to expose you to Seaborn and Plotly. But it's kind of going to stop at me showing you, one, they exist, and two, here's the syntax, just to see it's very similar to Altair. Maybe one more thing I'll say about Seaborn is I believe this one is built off of Matplotlib. Cool. So these are the three libraries we're going to see. And in some sense, they're all based on something called the grammar of graphics. So actually, before I go to that page, let me write it here. So I'll say based on the grammar of graphics. And this is a book by L. Wilkinson. In the second edition in 2005 is the one that I'll be referencing. And if you're a current student in our class, if you are on the UCI internet or you're using the UCI VPN, you can download this book actually for free. I highly recommend checking it out. It's really cool. And a lot of kind of the things we're talking about in this video come directly from this book. So, okay. Now, imagine this situation. I don't know about you all, but I haven't really thought about what goes into actually kind of getting a chart, right? Like, what does it take to actually write this pie chart, get it coded, that kind of thing? So here, kind of based off of the chapter in the book, it's called How to Make a Pie. So not the edible kind of pie, but perhaps a pie chart. and perhaps a pie chart here where you can see half your time is spent studying Math 10, and the other half of your time is spent sleeping and eating, and kind of the very basic, so let's call this data flow model. So this is kind of like data flow model of how to make a pie chart. And the very basic idea is, well, you start with some source, so you have some information, you get the data, then, okay, you make the pie, and I'm going to put a big question mark here, maybe 3 question marks, because what does that actually mean? And then then you render it. So we're not so much worried about the rendering. That could be once you have all of the components, maybe it's just, displayed on the screen. So it's the actual, how do the pixels on the screen present it? Perhaps it's rendered via, I don't know, a song, an interpretive dance. Basically, we're not going to worry so much about the rendering. Let's really focus on, well, what do we do to make the pie? What are the steps? So some things to think about. So I'll kind of do an arrow here. So things to consider. One, you can ask, well, what's the format of the data? So the data that you have access to, what does that actually look like? How is it stored? Another thing you might wonder is, well, how did I pick the color of the wedges? Like something had to decide that, right? So we could ask about color of the wedges, labels, that kind of thing. And once we kind of have an understanding of how to make a pie chart, well, why stop there, right? Eventually we'd want, so maybe I'll put here, eventually, we want things like scatter plots or bar charts. And the idea is, well, if we have a good enough idea of the internal workings of what goes into making this pie chart, then we should be able to extend it pretty easily to anything else that we might want to make. And kind of here we have another graphic from the book. This is from page 24, and this is supposed to show the internal process of making a pie. So this is not super important for our class, but I just want to show you what goes in to kind of thinking about graphics, that kind of thing. And what do I want to say here? Kind of key idea, or maybe like takeaway, is, let's see, how does the book say it? I'll probably paraphrase it, but I'll put it in quotes anyway. If you can learn to make a pie, you can make anything else. So paraphrase, but basic idea is this kind of pipeline of going from the source to the render covers a huge amount. And if you can understand how to do it for just a pie chart, so making the pie chart kind of covers all of these things, well, then it's very easy to extend this to a bar chart or a scatter plot. So maybe I won't go into too much detail here, but basically when we're going from source to variables, well, we have to think about, we have some data and we need to load our data into something that's usable for us, right? So this could be just loading into a data set. Then here, algebra, basically this is a way of combining variables. So you can imagine, let's say we're thinking about the taxis data set, right? So I have kind of one ride in a taxi and a whole bunch of different kind of collections of data about it, right? I know the number of passengers, I know how much the trip cost, I know the number of miles the car drove, and I want to be able to combine all of those data points basically into a row. So for us, a lot of this happens right away by using a data frame, but in the most general sense, we might need to do all of this by hand. Then you need to do things like scaling your data. So for instance, if I have data that's, I don't know, maybe like there's a rating system for the taxis, right? So maybe the customers rate the taxi ride from terrible to very good. I need some way of ordering that data. So this is where we could introduce it. Then I need to do some statistics on the data. So if I want to make a pie chart, maybe I want to kind of have a pie chart with all of the very good ratings, all of the meh ratings. So I need to kind of do an aggregation, for instance. And then this kind of last part of the pipeline deals with the geometry, right? How do I actually represent it graphically? How do I set the colors and the labels? That kind of stuff. And then again, we get to the rendering stage. So not super important for us, but why do I want to show you this? It's, well, there's a lot that goes into kind of representing data. And when I show you the syntax for Altair and Seaborn and Plotly, some of it might seem a little bit strange or confusing at first. So I want you to just keep this basic idea in mind, that this is kind of the order in which we need to do things. So it won't be this complicated for us. There's a lot that gets simplified in Altair, for instance, but again, really good book. I highly recommend you check it out. So back down to earth, what does this mean for Math 10? Here's the basic setup of how we're going to plot. So we're going to use a pandas data frame. So I'll say have pandas data frame. And what we want is to have each row corresponding to an observation. Each row corresponds to an observation. So thinking again about the taxis data set, each row represents one taxi ride, right? So somebody or a group of people got picked up, they got driven somewhere, and all that data we have constitutes one observation. Then each column is going to represent a variable. So each column represents a variable. And sometimes these are called dimensions or fields. I won't write that down, but sometimes you see that language. And then to produce the visualizations, we just need to specify, kind of encode different columns from the data frame into visual properties of our chart. So let me start writing. So I'll say to make visuals, encode different columns into properties of the chart. So you might just think of, a two-dimensional chart like this and a graph of points, but we could do more. We could represent 3 or 4 dimensions by doing things like, okay, well, what if I plot each point, but now the size of the point means something? I could also color. I'm thinking about a scatter plot, so maybe I have some set of points like this, but I could change the color to represent something. For instance, I could do different shapes. So there are really a lot of ways of encoding multiple dimensions of data. We don't have to just limit ourselves, to these points. There's really a lot more that we can do. So, okay, this is getting to be kind of a long video. I hope this gave a little bit of inspiration and is getting you a little bit excited to see how we're going to plot for this course. Thanks for watching this video. In the next one, we'll get right into plotting. So I'll see you there.